In this video, we're going to be looking at the simplest amino acid, which we call the glycine. On our previous video on the introduction to amino acid, which I'm going to drop the link down below in the description section, we made mention that each amino acid shares the same chemical core structure, and we have 20 amino acids in total number. But the difference in those amino acids is simply from the side chain group. Another name for the side chain group, we can have the side chain group, and another name for that is the R group. We can be given one carbon as the central carbon, and these are bonds that connect the other group, and this is what we call the side chain group. Also notice that the general formula for the amino acid, it has a central carbon. As the name suggests, central carbon, it has to be in the center. It simply has a central carbon, a common hydrogen, meaning hydrogen without anything attached to it, the amino group, and the carboxyl group. In this case, the amino group can be NH3, but with positive, if we have 3 here. NH2 without positive. So, the carboxyl group. And here we go with the R chain group. So, at this point, this is where every amino acid differs. So, using the general formula, how can we derive the structure of glycine? Notice that since we said all amino acids have to get this, this, and this, the only thing that will be changing is the R group. We can derive our general formula from this by saying we can have NH3 positive. And here we're going to have our central carbon, and here we're going to have our hydrogen up here. And remember, we said the glycine, like all other amino acids, have an amino group, carboxyl group attached to a central carbon, and we call this central carbon to be the alpha carbon. So here we're going to have the carboxyl group, and what we're going to have here when it comes to glycine is simply going to be hydrogen. But to make things ridiculously easier, you can just do it differently by saying, putting it this way. Let's say 2 hydrogen atoms connected to the central carbon, which is also known as the alpha carbon. Hydrogen, you can just, instead of hydrogen this time around, you can just put it, the carboxyl group can come on top. And here we're going to have our hydrogen, and the other hydrogen will move down. So this is the same thing as this. So what if you want to draw the skeletal form of glycine? So first thing you need to do when drawing these structures, ensure that you write your central carbon, also known as the alpha carbon. Also, even in the skeletal structure, you need to indicate that. So first thing we need to do is to indicate the central carbon. And this carbon is implicit in skeletal formula, so you don't need to mark it directly. You can just by placing a point here. From this carbon which we draw, which is this, next thing you need to do is to draw 2 lines. One will be moving by our left hand side, and one will be moving by our right hand side. And this line represents the bond connecting the carbon and the adjacent group. What are the other adjacent group? Which is the amino group and then the carboxyl group. At this point, you can add the amino group and then the carboxyl group, but make sure that the amino group have to be by our left hand side, and then the carboxyl group have to be by our right hand side. All right. The amino group, we can put H through N here, and then we can put the carboxyl group. All right. For us to put the carboxyl group, what we need to do is draw a single bond from the central carbon to a carboxyl group. Single bond that is to the carboxyl group would be something like this, right? So, and this, the single line, let's draw it this way. This one will be the one that will connect. What will it connect? It will connect to the OH group. So, in this case, we can put it this way, meaning that we are going to have one carbon here, double bonded to one oxygen. And then down there, we're going to have our OH. But if you like, you can also choose to put it differently by drawing it this way. The first central carbon maybe has to be from here. Then our left hand side, we're going to put the amino group. After the amino group, then we're going to have double bond here connected with one oxygen atom, then the OH group. So this is the same thing as this. Now that we have looked at the basic structure of the glycine, what do you think is the importance of this glycine in the biological processes? So glycine is a crucial amino acid that impacts protein synthesis and collagen production, also with nervous system function, and sometimes, or a lot of times, metabolism, among other roles. So it's also important in muscles health. You pronounce it as muscles, but Africans are basically me from Nigeria, muscle health, skin integrity, immune response, and overall cognitive function. So this is it for this problem, and I hope you find it helpful. If you do, please don't forget to click on the subscribe button. Thank you for watching, and see you next. In this video, we're going to be looking at the simplest amino acid, which we call the glycine.